When I came here to enroll the first time as a freshman, I wanted to take chemistry. But my problem was, I was in Clinton, Oklahoma, and I didn't have a car, so I had to have a carpool. And we were coming from Clinton, so we could enroll and then go back home. Well, I wanted to enroll in chemistry. I love chemistry, I love making all the chemicals. I was making rocket fuel, and we were making stuff to blow up and stink in the lab, and I loved that. But I also loved physics. But I went out there, and we were enrolling in a big gym, right away of gym at that time. And the actual line was so long, it was going to take me probably almost an hour to get through that line. Well, my carpool said, "Hey, we're ready to go home. If you don't hurry up, we're going to leave you." And then you hitch back. Right next to this long line for chemistry was J.R. Pratt by himself. Nobody there. He's dressed in a blue suit, white shirt, black tie. And so I said, "Okay, I like physics, so I'll go over there." So he saw me coming, he made a big grin, and wow, like, "Come on, sit down, young man." And he started writing out my class schedules while I didn't talk to him. So before we finished there, he had I think at least the first 2 years all ironed out, and said, "Here's what you're taking." I said, "Well, okay." Well, anyway, I went back home, caught my ride barely. Well, one thing led to another. I liked physics. I liked the way that Mr. Pratt presented it. It wasn't just a very fractional matter, not just with this equation. And there was just a certain bit of difference of dealing with us. We all wanted to learn more than just, we all needed to learn the philosophy of life more than anything. Anyway, I'm not going to talk about that, but that led me to be here. And what made it my first job when I got out of school had to do with going to Houston to work for NASA. At the time, I didn't even know NASA was going to have anything in Houston. I didn't even know where Houston was. I'd only been as far south as Wichita Falls, and I had never seen anything about that. Well, we had everything in our car. We went to Houston, got there, and all of a sudden, it came from my first day of employment, which, and somebody reminded me it was D-Day. It was June the 6th, 1962. So I went down. My first day was very interesting because there was hardly anybody there. They said, "Okay, who are you? Where are you from?" I'm a new hire. So, "Okay, we'll find somebody." Actually, somebody said, "Oh, come in here. Take this book, start reading it." It was a classified book about how the Gemini spacecraft was designed. I thought, just a few hours ago, I didn't know anything about this. All of a sudden, now I'm here reading classified stuff. Well, about a few days later, all of a sudden, the leader of our group, at the flight control of the branches at the time, was coming in town. They said, "Okay, Gene's coming to town." Who is that? What? "He's our boss." "Okay, well, we're in there." And so all of a sudden, here's my first time I ever saw this guy in my life. He comes in, he's dressed like with a fur haircut, white shirt, carrying a briefcase, and I thought, okay, this guy is we've kind of fun to work for, I think. But within a few, and I said that, but I had no idea what was going to happen. Within about 6 days, he had us in classes. Within a little over almost 2 weeks, I was on the very first plane flight I've ever had in my life, going to Corpus Christi for a training thing, which was followed by another plane flight to Cape Canaveral, Florida, which was followed by many classes in everything having to do with that stuff I studied in school. Physics, wow. Chemistry, wow. And all of a sudden, I like this. Well, 50-some years later, we're here tonight. And the first time he's ever seen this little school that presented all of our so forth. And so now, let's just say it gives me great honor and happiness that he came to see our school and here in Oklahoma. And he's also the author of Failures Not an Option. Except for my introduction being a failure, I will introduce Gene Kranz.
Okay, folks, I'm not Gene Kranz.
You read me in the back? I can't use these boom mics up here because I arm wave and I tend to hit them. Sometimes I knock them off and end up on the floor. And I get charged for breaking the equipment here. You know, it's really great. I was very happy when Jim asked me to come up here and talk. Because I'd always wondered what this little school in Southwest Oklahoma was all about that produced such darn good people. You know, basically, school produced a bunch of giants in the business of mission operations, flight control, trajectory design, you name it. Basically, you produced the people that made things happen. So I thank you. Tonight, we're going to do a little bit of an experiment. Last summer, I was asked to do a talk at the Smithsonian for what they call Flight Jacket Night. And Flight Jacket Night is basically the one night a year where the Air and Space Society comes together and all the aviators come in there and they all wear their jackets and they're all puffed up and they tell war stories. And I was following a couple pretty tough customers. Jim Lovell spoke 2 years ago, and then Hoot Gibson. And Hoot Gibson flies, Reno races, and all that kind of stuff. He has all kinds of stuff. But I said, I don't have any good war stories that would compete with these, but what could I do? I decided this is the 50th anniversary of the first lunar landing. And fortunately, we found some 16 millimeter film in mission control that had never been used before. And one of the things that's been an irritation for me for an awful long time is that they always talk about the crew end of the job. They always talk about the final 3 minutes when the crew's getting ready to land, but they never talk about the people and the team that got them there. So I decided I'd take these pieces of film and make a silent film, which you'll see in probably about 15 minutes. And I'll do a narration of what was happening through the early portion of descent based on my log, the crew's debriefing that had many interesting things in it, particularly a lot of the concerns that Neil was having about the time he was seeing these program alarms. And I took this, wanted to make sure it was right because I'm now going to speak to all my peers up in Washington. So I had vetted Steve Bales. Steve Bales and I had some pretty good discussions on what this talk was going to be about. We got into some debate because he said one thing and he said, no, I didn't say that, it must have been somebody else. So, and then Chuck Dietrich was in there, I had Jack Knight do a quick check on it. So this is, to me, the story that basically carried up the Smithsonian. Now, there's one minor change. The Smithsonian, the introduction to the story was basically to a bunch of aviators in there. So I turned this into aviation language, and I did a lot of the details of the trajectory stuff that for the general population I don't think would go over. So basically, let me give a start. The one thing that was interesting going through this and doing this was I got a chance to really have, I won't say flashbacks, but basically I was starting to live as I was pulling this thing together, the details of that particular day. And as I listened to some of the voice traffic in there, all of a sudden I could hear these guys, and all of a sudden I'm starting to live this thing, which is really a blast. This year here is going to be very special for us. We've worked 5 years to restore the Mission Control Center in Houston. And we spent almost 5 years in the process of the restoration. And it's going to be pretty slick. It's going to look exactly like it was the day we left Mission Control. We went down into the details that we found the exact carpeting, and we went to the manufacturer and got exactly the same loom, the carpet, the same color. We did the same thing from the wallpaper. We got the wallpaper rollers. Believe it or not, we advertised out on eBay, and people that had taken stuff home from Mission Control now started sending it back. So it was really, this has been a really great experience. Few comments on my background in NASA. When I was growing up, all I wanted to do was to fly fighters. I grew up in a military boarding house, and I was surrounded during World War II by the soldiers, sailors, and airmen who were flying the battles in the Pacific and over Europe. I went through flight training, and I always wanted to fly the Sabre, which is the big killer. You've got a model, you've got one of the Sabres, it's the same one version. But you got a Sabre out there, and it was really a marvelous aircraft. It was the first of the swept wing devices, and it was, as I say, the ultimate sports car. I made a flight leader over in Korea, and I had the opportunity to be responsible, not for some event right on the line, but basically for the 3 crew members I had in there. I would teach the young pilots to fly, fight, survive, and win in the skies over Korea. And this was an awesome responsibility for me, because this was very personal, it was very intimate, it was minute by minute, working with these people to make sure they were the best possible. Returning from Korea, I became a flight test engineer in the B-52. At that time, the Soviet Union had developed surface to air missile capabilities, and basically I had the bomb bay, and I filled that bomb bay with technology and various drones, things we could deploy to confuse the Soviet system. And this was a really great problem because it taught me, gave me a very good background to go a few years later into NASA. And as this program was ending, it was very successful. I saw an advertisement in Aviation Week magazine that indicated that they were forming a space task group and they're looking for qualified engineers to determine the feasibility of putting an American in space. I reported to Langley, and for the first couple of weeks I was just completely bored. I was used to the desert, I was used to cranking engines, flying 2 flights a day with our aircraft, and all of a sudden a gentleman walks in and taps me in the shoulder. His name was Chris Kraft. And he says, "The red sun's on the launch pad. I want you to go down to the Cape, write a countdown, write some mission rolls, and when you're done, give me a call and we'll come down and launch." And this was my first experience in a launch. We didn't launch the rocket, we launched the escape tower. And this escape tower took off and basically zoomed up to about 3,000 feet and then came plummeting down the viewing stand. Senators and congressmen ran for cover. The parachutes billowed out of this thing here. They inflated with the breeze coming in off the ocean, and we didn't know what to do. But we were fortunate in those years because our nation understood there's no achievement without risk. And there certainly weren't any guarantees in this new business that we called spaceflight. Our first year down the Cape wasn't very good. 1960, we just couldn't seem to get things together. Then in 1961, a young, brash, and articulate President John F. Kennedy made a speech. He said, "We choose to go to the moon. We choose to go to the moon in this decade. And do the other things, not because they're easy, but because they're hard." And that's interesting. When he made the speech, 1 month prior to the speech, we had blown up our second Atlas rocket. 2 weeks prior to the speech, we had launched Alan Shepard, so we had a total of 20 minutes manned spaceflight experience. We'd never been to orbit. And we were challenged to go to the moon. So engineers became experienced with flight tests. Small group of 31 Canadians and Englishmen joined with the Mercury 7 astronauts at Langley Field in Virginia to form a space task group that would win supremacy in space. Our boss was Walter C. Williams. Walt was a brawler. He was the toughest man I've ever known. He's probably more fitted to working as a longshoreman in New York or New Orleans or San Diego than leading a space program. But in the business of aircraft flight tests, Williams was a legend. He was the pioneer director of the NACA high-speed test station that today we call Edwards Air Force Base. And he's a project manager for the X-1 rocket ship that in 1947 took Chuck Yeager and the world into the age of supersonic flight. Williams' deputy was Christopher Columbus Craft. What a name. Chris was the pioneer of early spaceflight operation. He wrote the book on operations, launched each one of the missions, but most importantly, he was the mentor, the teacher, the tutor for the first generation of young people that became known as mission controllers. Mercury Control did not have a single computer. There are only 3 mainframe computers supporting all of Project Mercury. 2 of these mainframes were located 700 miles north of the Cape of Goddard Space Flight Center in Greenbelt, Maryland, because IBM did not trust us to operate these first fully transistorized computers. On the island of Bermuda, we put a reliable vacuum tube computer with a small team of several controllers. We had 13 tracking stations around the world, and we sent young men to these sites that were literally at the ends of the earth. And the risk was very high to these people because this was the end of the 60s colonial period. And many of these countries they went into were in a state of civil war or revolution. The communist revolution was transpiring in South America and even down in Mexico. But these people were our eyes, our ears, and voice as the spacecraft passed overhead, and for they were given incredible responsibilities, and many of them grew to be the leaders in Apollo. We put 6 Americans in space in our first 2 years, and there were close calls in every one of those missions, especially in John Glenn's and Scotty Carpenter's, but we got every one of our crewmen home. We finished Project Mercury, and we learned to put man in space, but we learned much more. We learned of leaders and leadership. Leaders have integrity. They're teachers. They're team builders. They're great listeners when there's trouble. Leaders get out front. So we moved into the Gemini program, and Gemini was the precursor that we needed to develop the teamwork and the technology to move further into space. And when we first started off in the program, the Soviet Union was about 2.5 years ahead of us. When Ed White stepped outside of the spacecraft in the Gemini mission, we had now narrowed that lead down to mere months. And then on the next missions, for the first time, we set American manned spaceflight records for mission duration and rendezvous. And when we had accomplished this rendezvous, we had developed the technology we needed to reach further into space. Now time to go to Apollo. Gus Grissom, Ed White, and Roger Chaffee were the crew of the Apollo 1 mission. And Chris Kraft, myself, and John Hodge were the flight directors. And we were on the launch pad testing Friday afternoon, January 27th, 1967, when fire exploded in that spacecraft and we listened to our crew die. And with their death came anger at ourselves because we knew we were responsible for America's first space failure. We continued on, however. November, we got back into space again with the Saturn V launches, launch 501 and 502. We developed the values, what we call the foundations of mission control. And we set the standards for performance in our organization: discipline, morale, toughness, confidence, commitment, teamwork. Because as a team, we must never fail. The flight director is the boss in mission control. And it's interesting, his job description is only 1 sentence long. Flight director may take any action necessary for crew safety and mission success. That's the job description, but the real word is accountability. Because if that mission fails, the guy that had the responsibility for that mission is the flight director. He has to stand in front of the world and his team and say, I didn't do my job. The program continued. We launched Wally Schirra. The Apollo 7 mission was successful. And then we continued on. Apollo 8 gutsiest mission we'd ever flown. We took that guy to the moon. And listen, this is the picture that was probably one of the key pictures of the prior century. It's called Earthrise. And December 1968, Christmas Eve, we listened to the crew reading from the book of Genesis as they circled the moon in the final revolution prior to coming home. We had set the target. We'd been to the moon, but now it was time to go further. We had Apollo 9 and Apollo 10, and all of a sudden it's Apollo 11 time. We have a crew, Buzz Aldrin, Neil Armstrong, Mike Collins. They were the first. They were going to be the pioneers, the pathfinders. And it's interesting, I worked with both Neil and Buzz. It was almost a miracle because they were the Capcoms of my first mission ever as flight director on the Gemini 4 mission. They were a great crew. I had the, I won't say the privilege, but I had the responsibility to get Neil and Dave Scott down in the West Pacific landing area after we had a malfunction on board the Gemini spacecraft that caused us to spin up, and we had to use all our fuel to kill those rates. Getting ready for the final mission, the flight directors for the Apollo 11 were Cliff Charlesworth. He was a green flight director. He would handle the launch in the EVA. Glenn Lunny was the flight director for the lunar ascent. I had the lunar landing, and Milt Wendler was the maroon flight director. I got a cold, so I'm having a bit of trouble here. I thought I'd take a break periodically. The control teams were spectacular. Our controllers that were working in mission control in those days included a World War II B-17 pilot, another who flew round trip across the Atlantic in a single engine Blanca, a Marine who fought in the battle at the Chosin Reservoir. This was the nature, the people that we had. Each one of them had a mission, and they sensed that mission when they came to work for us, and they performed in that mission. Many came from the farm, my recruiting zone. For when I was in Houston, it was basically the central United States. So basically we got the farm boys from Oklahoma and Kansas, Nebraska. We got the students out of Purdue, we had Aggies, we had Longhorns, but basically it was just a marvelous area of the country to basically get our people. One of the things that we did, and I see Holkins back there. It's interesting. They mastered the business of training for us, and they taught us what training was all about. They prepared us. They were ruthless in the way they handled us. Basically, they got us ready, and when they finished, we knew we were ready. I'll talk a bit about my instructor for the Apollo 11 landing shortly. Mission roles. Mission roles, I brought this up, this one page, because as we went down towards the moon, we had 4 major mission roles that we were challenged against or to solve all the way down. There was one role that talked about communications. We don't have a crash recorder on board the lunar module. So if for some reason we lost that spacecraft, we had to have data, and that was my job to say we had enough data to continue. The guidance officer had a variety of navigation challenges because of an undocking issue. Steve Bales had problems with the computer program alarms as we were going down towards the surface. And then finally, the guy calling out when the rest of the room was silent was really calming down the seconds of fuel remaining. Basically, mission roles are basically I think the key instrument in our success in mission control, because we literally spent about a third of our total mission preparation time debating what are we going to do if. They point out the initial sense of direction. Go back to Apollo 13, basically, that we really had the starting point based on the mission roles that we had worked with the team. So we knew each other, and we knew what our bottom line was from each one of the controllers or management that we were working with. We launched Apollo 11, Neil Armstrong, Mike Collins, on July 16th, 1969. And this launch was literally beautiful. Launch translunar injection lunar coast was basically uneventful. And 3 days into the mission, the dock spacecraft were inserted into a 66 by 54 mile lunar orbit. Coming up the next day, I'd be taking crew down to the moon, so Saturday evening I went to church and received a blessing from our pastor. Sunday, July 20th, 1969, the eastern horizon was just starting to show light as I hit the road. And when I arrived at mission control, several controllers passed me by, and there wasn't any conversation or giving me privacy. We had a Negro guard up there, Moody, and he was out in the parking lot, which is strange because we normally didn't have guards out in the parking lot. And he said, "We can land in the moon today, Mr. Kranz?" And I nodded yes. And then we saw another guard in the lobby as we walked into the control room. And he gave me a salute as I entered the elevator. 3 floors up, I walked down the narrow gray hallway to the control room. And my job as flight crew, I'm tasked to take any actions necessary for crew safety and mission success. And I lead a team of young controllers whose average age was 27. Our target today is the moon, traveling at 2,287 miles per hour in its orbit. It is mountainous, pelted by micrometeorites and with craters 180 miles across. Its gravity is 1/6 of Earth's gravity. It has no air, no moisture. And the temperature range is plus or minus 250 degrees. This heavenly body has never seen an earthling or felt a footstep. Entering the control room that day, my reverie ends. The front of the room has a gray hue reflecting from the display of the dock spacecraft traversing the 10th orbit of the map of the lunar surface. I go up to the flight director's console, Glenn Lunny's flight director. My white team is already in the room, studying the console logs. I sit down next to Lenny. Says, "How's it going?" He nods and he says, "It's all peanuts." It's been 36 hours since I was since my last shift, so I got a lot of reading. Then I go to the spacecraft analysis room to review the spacecraft discrepancies. I then visit my simulation team. And I'm concerned because Dick Coos, my simulation supervisor, is not there, which is surprising, but his team is there. Our confidence comes from the relentless work of these people who trained us. I complete my handover with Lunny at the beginning of the 11th revolution. My white team is now briefed and ready to go. Members of 2 other teams now are sitting behind us. All I hear is a quiet murmur of their voices. Sitting next to me at the console is Bob McCall, the space artist. And I marvel as how he sketches rough pictures of the controllers in the room. 30, 60 seconds sketching on to another one, on another one. It's almost impossible to just pull yourself away from him and get back to work. Slide 34, Rev 11. The spacecraft is emerging from behind the moon. And the telemetry indicates this crew is entering the lunar module. The voice and data quality is excellent. The telemetry for the first time on the mission, as each system comes alive, I can feel the excitement of my 11 controllers. Rev 11 passes swiftly as my flight planner, Spencer Gardner, indicates the crew is well ahead of the timeline. Most of the time, we're just looking over the crew's shoulder as they activate the LEM systems. And without being asked, retro sets the clock to 2 hours and 47 minutes. It starts counting down to the undocking go-no-go. An adjacent clock begins counting down the separation go-no-go 25 minutes later. To get the pulse of my team, I eavesdrop on them. I call up their backroom loops. And the team sounds great, no jitters, they're cool. No indication that the day is any different from the hundreds of hours that we've spent in this room for previous missions. Midway through the 12th revolution, the crew has activated most systems. And we've been a long series of critical data uplinks, the LEM and command and service module computers. The crew has donned their helmets and gloves. Attitude control, hot fire checks, and the initialization of limb primary and guidance system is complete. Approaching loss of signal. It is time for the go for undocking. I pull my team. All controllers give me a go. Capcom passes the go to the crew. The event clock is now reset to 1 hour and 10 minutes for the separation midway in the next revolution. The density of the work is now increasing. The clocks are the heartbeat, and they're now all important. Limb undocking, just part acquisition of signal, the limb undocks and deploys the landing legs. The mission control room now splits in half. Part monitoring my columns in the command module, and the rest are monitoring the lunar module. My team now compresses to just 6 controllers, and they're all a cross-section of the nation. And their lives converged at mission control for this event this day. It's a retrofire officer, Chuck Dieter from Bloomberg, Pennsylvania. Flight dynamics officer is Jay Green from Brooklyn, New York. Guidance officer is Steve Bales from Ottawa, Iowa. Bob Carlton, Ottawa County, Alabama. He quit school in the 10th grade and joined the Air Force. He's my limb propulsion controller. Telling you is Don Putty from Ponca City, Oklahoma. Limb communications, power, and life support. And my Capcom is Charlie Duke, astronaut from Charlotte, North Carolina. And I'm the flight director. I'm from Toledo, Ohio. Collins in the command module performs a visual inspection of the limb as it slowly rotates for its inspection. Collins is looking at the limb, comments, and says it's sure a fine-looking flying machine. Capcom Duke's console is now filling up. All the astronauts are now sitting behind him, and 2 astronauts plug in. And I tell them to move back from the console and give my Capcom room. During the pass, we're back in the flight plan. We send many computers, data sets, state vectors and targeting for the descent orbit injection of the powered descent. We send up the contingency data loads in case of the abort. And another set is sent to both spacecraft in case we have to wave off the first attempted powered descent. During that pass, we send a total of 15 data and maneuver loads to update the computers. Additional backup data is voiced by the Capcom, and the controllers cross-check every word that is said. The separation clock now reads 5 minutes, and I pull my team, and again, all are go. Duke passes the separation of the crew, and I fumble for my cigarette pack. The Zippo lighter rasps as I light up. The front side pass seems just a single continuous set of actions as the minutes count off the clock. Throughout the pass, we continue to evaluate the limb status. 10 minutes prior to loss, I again pull my team for the descent orbit injection maneuver. And momentarily, and this is true, I feel like a conductor with my team preparing for the massive finale of a great symphony. My team is go. Capcom slowly and formally passes the key words, Eagle. You are go for descent orbit injection. The descent orbit injection is a retrograde maneuver performed behind the moon. The descent engine burn time is 28.5 seconds, and the orbital velocity is reduced by 70 foot per second, which allows gravity to now start pulling the lunar module towards the surface. Behind me is the viewing room. It has 74 seats. It is crammed with the NASA hierarchy and the political, every politician in the world that could cluster in that room is there. To the left behind the glass is the media. Members from the TV, radio, and newspaper reporting live from mission control. I wonder if those in the viewing room are starting to feel distress. 40 minutes after the limb loss, the lunar module behind the moon, and provides a welcome relief from the workload. We carefully debrief all actions during the pass. There's no open items. And I provide the team a brief restroom and smoke break. Leaving the room, I sense my team's feelings. There's no chatter. They're just moving. Flight Director Charles Worth, sitting behind me to my left, lights up. Cigarette, another cigarette, and I decide to join him. And blue, pungent smoke of cigars, the row behind me fills the air. They're blowing it past me. Seated behind me are great respected leaders, Dr. Gilruth, Chris Kraft, Sam Phillips, and George Lowe. An adjacent council are the program directors. These leaders, irrespective of their seniority in NASA, at this point are just observers. My team and I have absolute authority, and with it, total responsibility. When my team returns, I direct the controllers to a private loop used for debriefing. Only my team will now hear my words. When I say today is our day, the hopes and dreams of the entire world are with us. This is our time and our place. We will celebrate this day and what we will do here forever. The risks are very high. That is the nature of our work. We work long hours and have the nature of our work is high. We have mastered our work and now are going to make this work pay off. You are a hell of a good team. What I'm privileged to lead. I will stand behind every decision you will make. We came into this room as a team and we will leave as a team. And I direct the controllers to return to the flight director's loop. And I call the ground controller to go to battle short. The power breakers in the building are now blocked. They can't open. And the control room doors are locked. No one will enter or leave this room until we have landed, crashed, or boarded. I remove the clutter from my console, move the coffee, cups, systems, and handbooks. The ashtray is put in the right-hand corner of the console. My action is now focused with my log and two large time-oriented sheets, one for landing and the other in case we abort. They contain decision criteria, go, no go locations, key events, decision points. In the few remaining minutes prior to acquisition, the control room gets quiet. Have some more water. The only question is, did the crew perform the maneuver? Two clocks are counting down to acquisition. One for no maneuver, the other if the maneuver was performed. Retro sets the clock for the powered descent. It starts counting down from 18 minutes. I think the final movement of the symphony is about to begin. Network announces command center's module acquisition. Seconds later, Capcom calls Columbia. How did it go? Command Module Collins responds, everything's going swimmingly, it's beautiful. T-minus 16 minutes, my communications loop come alive. All reports are terse now, short of useless words. AOSLM, flight, TALCOM, then low bit rate, and bird attitude. 3 reports from controllers, 11 words. Aldrin reports the descent orbit burned is on time. X and Z residuals are null to 0, a perfect go. Loud static overwhelms communications, telemetry is ratty. Valuable time and data is lost. 1 minute has elapsed, we still have no data. Capcom tells Collins, tell Eagle to manually require. It works, data's back. Without my asking, controllers report their statuses go. The voice again becomes ratty. Aldrin continues the maneuver report. Guidance gives me a go. The trajectory conditions are now set for the power descent. Excuse me. I comment to my team, we're off to a good start. Play it cool. The module voice and data is now solid. We monitor the crew configuring the spacecraft for descent. It's 11 minutes to engine start. 6 minutes till the go, no go. Precious seconds of data and voice are lost. Again, the noise overwhelms communications with my team, and I need the data for the go, no go. If we don't get data, I will have to wave off descent to the next and the final revolution. Variety data and static continues down to 9 minutes and still no data. Capcom asks Collins and the command in Columbia to ask Eagle to try and reacquire on the high gain antenna. The Goldstone, California tracking station advises they have no downlink data. I tell Telecom to try the Omnis. At T-9 communication data is back. Alden reports he doesn't know what the problem was. The data is solid. We monitor the abort guidance system initialization and report to the crew it looks good. The alignment's complete. I toggle 22. Now we're both looking at the same data with my flight dynamics officer. Then the noise returns. Telemetry and Capcom are again battling to restore data. In desperation, we select lower data rates on the antennas. It's decision time. It is my job to assure we have enough data so that if we crash, we'll be able to establish the cause. My thoughts at this moment, the spacecraft is in good shape. We're configured for power descent. LEM systems look good. The crew and my team is ready. The only problem is comm. We have the next 5 minutes to find a solution. I also have the option to begin the descent and continue for 5 minutes to troubleshoot communications before we would need to abort. I believe the communications is a pointing problem that we can solve. I decide to commit to descent. Excuse me. Got a minor, there we go. Here's my homemade movie. Okay. It's 102:28 mission lapse time. I pulled my team, but I'll go. The energy in the voice signals confidence. I said, Capcom, are you go for power descent? Capcom says, Eagle, if you can read, you are go for power descent. Through the noise, I can hear the Eagle's response. They recognize they go. There are two computers in the LEM. The abort guidance system is a backup to the lunar module computer's primary guidance system. We advise the crew, we confirm the abort guidance system is aligned to the primary system. During descent, the LEM computer sequentially executes the program for braking, approach, and landing. The braking phase is designed to reduce the orbital velocity. The crew is now oriented feet forward, face down to allow verification of the ground track using lunar surface landmarks. After I've given the go for ignition, I have an agonizing few minutes and pray that nothing will make me no-go PDI. I got a bunch of problems, all are related to communications. We give the crew a time hack, 2:30 until engine start. Fido advises the trajectory is a bit low, no problem. The comm again drops out. We call Collins and CSM and tell them to have Eagle to go, that he is go for power descent. Procedures calls and battle short, doors are locked, all records at flight speed. From now on, it's just my team and the crew. T-minus 1 minute. Yeah. Everybody's trying to give me a hand here. Okay, LEM control indicates we're in burn altitude. Engine has been armed. There's total silence in the room. No one is moving. All are intensely scanning their displays for anything that would no-go the descent. Nervously, I pull my system guys. There go. I mentally review. There are 2 rules for engine start. If there is no all leach at the engine start command, I'm going to slip the descent 1 revolution. If there is all leach but no auto engine start, the crew will manually initiate the start. 103, 3304, MAT, engine start. T0, Armstrong keys proceed. The descent engine thrust is 10%. 20 seconds later, the engine goes to full thrust. Descent guidance is initiated. The LEM control reports the engine is armed, always 10%. Sustained static now obliterates the crew's voice. LMU advises Capcom, have Eagle use the comm antennas on the antennas. The noise continues just as the engine starts. Every member of my team is trained to hear what the controllers and crew are saying. Capcom is telling you, fight to restore the comm. They revert to the Omni antennas. We're now back on low data rate. 1 minute, final reports tracking data is lost. Guidance indicates that data indicates a 20 foot per second residual, probably due to downtrack error. Final reports mission control computer is dropped out. They're restarting. Tracking data is lost. Controllers, without my request, after get data back, report their status. I go. The first burst of valid telemetry confirmed the radial velocity air. I glance up at the large screen. The plot boards are in the front of the room. The data is just starting to appear on the plot boards. It looks good. The LIM computer is doing the job. Capcom advises Eagle. All is looking good in mission control. We're killing orbital velocity, sending now 34 foot per second. The next go goes in 2 minutes. Eagle reports AC electrical fluctuations. We advise no problem, must be the meter. At 60 seconds, the LIM's going to roll face up. Now, as the descent continues, it will pitch over, providing the crew a view of the landing surface and landing point. The crew reports landing tracking data indicates they're a bit long. We confirm long. We have static again. There's a lot of popping and crackling. We need data for the several critical events coming up. Data is briefly in and then lost. I advise controllers to use the last data they saw for their go. Data comes back. I give the controllers a few more seconds to review data for the go. I pull to continue the descent. Retro, FIDO, guidance control, TELCOM, GNC-COM, surgeon, they're all go. Guidance did not need the intercom. He pumped the yells. The whole room heard him literally yelling. There are snippers from the controllers. We give Eagle the go to continue powered descent. At 4 minutes, now we're looking for the LIM radar. Up to this point in the descent, the computer has been using altitude data provided by mission control. To land, the computer needs actual altitude provided by the LIM radar. If the radar has not been obtained or the altitude is not converged, the landing will be aborted at 10,000 feet, 4 minutes, 40 seconds. Data drops out. We're at 35,000 feet, descending at 132 feet per second, 50 miles to the landing site. Guidance reminds me we need the landing radar by 18,000 feet. If he has to make Guidance has to make the comparisons and need time to advise the crew to incorporate the radar. Loops are silent, then data comes back again. Guidance calls, we got radar data and it looks good. The crew confirms they got data. Del H, the altitude difference is 2,900 feet, spectacular. Crew reports they got the Earth right out the front window and asks if we're looking at the Del H. I glance briefly at the front room displays, 30,000 feet, descending about 140 feet per second. Guidance says Del H is beautiful. Crew reports a program alarm. Seconds later, it's a 12:02. There is silence for several seconds. Guidance switches from looking at the radar data to address the alarm. He calls his back room. In a split second, I think our final simulation will include bloodiness and training with the program alarm. The approach phase is very demanding to computer resources. This is interesting. We did not have a CPU measurement. It was LIM computer was that stuff. We did not have a CPU measurement. And it was normally running at 83% normally during the descent. And basically when we get the alarms, it racks it up to about 95%. With no CPU telemetry, the computer was almost over the edge. And guidance had no way of knowing it. The computer is then shedded as a result of these alarms. Lower priority tasks and smart only guidance and control. Coming braking phase is going to be even more demanding of the computer resources. The crew gives us a go. Did we read the 12:02? Retro calls, throttle down, 8+25. Guidance officer in Bales and Garmin and asks NASA software guru to assess the guidance control functions. They're occurring properly. Guidance gives me a go to continue. Communications reached a crescendo in the preceding 60 seconds. Urgent, intense, critical, 6 minutes. 27,000 feet, descending 132 feet per second. Guidance gives calls. We are going the 12:02 alarm. I repeat, go on that alarm as long as it does not reoccur. I remain catacomb with the throttle down time. Servo antenna is now holding, pointing. I thank God for favors. We have a solid data now through the key parts of the descent, the data we need to land. I mentally go through the rules for the final go. From my standpoint, everything is working. I verify that the landing radar has converged. Guidance confirms go. 7 minutes, 20,000 feet, down 150 feet per second, another max descent rate point. Aldrin says we may lose data in pitch over, then he requests estimated switchover time. Armstrong reports manual control is good, then he switches back to auto. Control report switching back, now continuing descent in auto. Here's one item from the notes. The commander's window had a grid on it. There's an inner and outer plane, and they had scribe marks on it. And basically the crew could call up what to call index point to look at his landing point there. Armstrong is so busy he is not doing that, which is now going to cause him to have to really make some drastic changes low down. Neil's concern was whether he could continue at all, his exact words. We're coming up, the go for landing, we've met all the criteria. I pray that the program alarms don't continue distracting the crew any further. 9 minutes. Without knowing it, a full minute has passed in almost 6,000 foot altitude, now 3,000 feet. We're reestablishing the high descent rate. Armstrong takes manual control and redesignates down the landing point designator, then switches back to auto. So now he's trying to switch out and work around the problems he sees in the sight up ahead. At 1,500 feet, Armstrong saw the auto system was taking him to just short of a large rocky crater in a large boulder field with rocks 2 to 3 meters in size. He felt he could not land short of the crater, so he has to fly over the crater. He has to make sure he's far enough over so he's not going to dig in on the backside. From here on, if we're now in the area that we call the dead man's curve, from here on, if there's a major problem, the only solution is to land for Neil to land and then abort. At 200 feet, Neil knows that there is a transparent sheet of moving dust that makes it hard to pick out his landing, his lateral and downrange motions. And he has to look through the dust and pick out rocks and stationary objects to set up and base his translation on. From now on, you know.
Two, all flight controllers, 20 seconds to go for landing. Eagle, you're looking great. Okay, all flight controllers, go for landing. Retro, go, Rhino, go. Guys, go. Control, go. Calcom, go. GNC, go. Econ, go. Surgeon, go. Capcom, we're go for landing. Eagle, Houston, you're go for landing, over. Roger, understand, go for landing. 3,000 feet. Flat alarm. 1201. 1201. Roger, 1201 alarm. 1201 alarm. Stay tight, we're good, flight. We're good, stay tight, we're go. Flight center right on, real good. 2,000 feet. Into the ag, 47 degrees. Roger. 47 degrees. How's the margin looking, Bob? Yeah, that's okay. Okay, we're not. Roger. Eagle looking great, you go. Roger, 1202, we copy it. How you doing? Pretty fine. We look good here, fine. All right, how you doing? Go, guys. You happy? Go. 700 feet, 21 down. 33 degrees. 100 feet down, 19. 540 feet down at 30, down at 15. And feet home. Okay, at hold. 300 feet down, 3.5. 47 forward. Hold up. 1 minute. 1.5 down. That's the time over. 50 down at 2.5. 19 forward. Okay, Bob, I'll stay back here. Go on, shut it. 2.5 down. 20 feet. 15 forward. 11 forward, come down nicely, 200 feet. 4.5 down. 5.5 down. 650, 6.5 down. 5.5 down. 9 forward. Low level. Low level. Good. 620 feet. 100 feet, 3.5 down, 9 forward. 5%. 105.
His heart rate at that point was 160.
65 feet. 6 forward. 60 seconds. 60 seconds. Right side. 20 feet down, 2.5. Pick up some dust. 3 feet, 2.5 down. Face shadow. 4 forward. Then 4 forward, turn to the right row. 30 seconds. 30 seconds. Forward 15. Contact right. Okay, engine stop. Tranquility base here. The Eagle has landed. Rocket 20. Tranquility we come to you on the ground, you got a bunch of guys about to turn blue, we're breathing again.
Record the landing time. This here is a significant point because it's vastly different now. You see, the lunar module is stationary over tranquility, while the command module is now continuing its orbit along the moon. I don't know how long I've been holding my breath through these final seconds there. The one thing that was really strange and again unexpected after the landing is the people in the viewing room started cheering and landing and pounding their feet. And you want to talk about a queer feeling getting into the room, and it's a real shiver. But basically, we had to stay on the job. We had to go through a series of 3 stay-on-stay decisions. At 2 minutes, 8 minutes, and 2 hours, we had to stay focused upon that spacecraft and make sure there wasn't any problems that would cause us to lift off. But I yelled back at the program manager behind me to cut it out, we got work to do here. We go through the T1 stay-no-stay, and it's really hard to stay, not get emotional at this point because I am so damn proud of my team at this moment that it is really, really difficult. Literally my voice croaked worse than it was tonight. And I pull my team, they go through the retro stay, FIDO stay, guidance stay, control stay, telemetry stay, surgeon stay, Capcom, we are stay for team 1. Charlie Duke then advises that Eagle stay for team 1. Armstrong responds, Roger, we're pretty busy up here. We monitored the lunar module for 2 more hours, and then we initiated power down. We gave the crew the time 3 stay and handed over to the EVA team. And it's interesting, while the rest of the world's celebrating, we're busting our butt in mission control, making sure everything is good. The one thing I didn't like about one of the movies, they didn't have a movie showing the flag deployment. So I included it in mine here. This is the flag deployment. There's another segment we have here which is interesting. We had a sweetheart deal with Cigar Institute of America. Basically, they provided all of our cigars. And we distribute them not only mission control, but basically out of the various plants out in California, Downey, and over in the Bethpage. And this is probably the sweetest smoke I think that any of us have ever had. We celebrate our mission. We started this tradition of the flags. Jerry Bostic, one of the trajectory boss, basically after our first lunar rendezvous, I mean the first time we had not the rendezvous, after the first rendezvous back in Gemini, went down to the mortuary and bought a whole bunch of flags back. And they started passing them out. That started a tradition. We carried that tradition through most of the Apollo, through all the Apollo programs, through most of the shuttle. But they went to T90 little flags after that. They found it was just too expensive. Close this evening with words from President Theodore Roosevelt. And I think this talks about the people, not only mission control, many people right here. We knew the triumph of high achievement. And we failed, at least we failed well, daring greatly, so that our place will never be with those cold and timid souls who know neither victory nor defeat. Thank you. The people you provided that made all that happen, gang. I was sorry for that. I got that cold day before yesterday, and I was really considering scrubbing out. But failures is not enough. somebody said they wanted to sign some books, so we'll sign for about a half hour, that's, the people got books. Yeah, we're gonna go outside there. I'm glad, I wish I'd tried this class.